couple minutes on it. So I teach software engineering and software engineering project management as part of my other teaching duties, in addition to teaching modeling courses. And much of what we're doing in building models draws directly on experience and principles and practices associated with software engineering. We're building software artifacts. We don't like to think of it perhaps like that, but the fact is we're building a specialized type of program, and there's a huge amount of wisdom and knowledge and tools that have been built up in this other area that directly shed light on best practices in modeling projects. And there's a set of principles that come out of both technical and process side out of the learning of software engineering that apply and carry over into simulation modeling. And I'm going to see if I could just mention some of the most important ones of them. The first is the use of peer reviews to review models. These are reviews of model artifacts and other items related to the model, such as maps, modeling maps that are used early in the modeling process, model scope documents, and model output, for example. And when we say peer reviews here, these run the gamut from highly informal means such as pair modeling, which is a process that I think is dynamite. We've used it in our group to very good effects, but I don't see people talking about it in general. But it's one of those processes that was inspired by software engineering processes that I thought I'd share with you. It may seem counterintuitive, but software projects gain a great deal of benefit out of having two individuals work on the same artifact at times, because they have two sets of eyes and, more to the point, two brains thinking about what is required. It's a process that can help improve quality, help enhance the spread of knowledge within the team about how the code works, as well as spread understanding of best practices and stylistic issues. So when it comes to reviewing models, while it may seem that it's a waste of time, I would argue that pair modeling often yields real dividends in terms of enhancing the viability of the modeling process. We've done this in our lab on some models, and the experiences has been really enjoyed by those engaging in it, and they felt it's very helpful. Sometimes it involves taking someone who's more from the requirement side or the domain side and pairing them up with someone who's more technical. And both sides learn from each other greatly in the same session. Rather than the technical person going off and doing something, bringing it to the domain person, having them look at it and critique it, they're there sitting next to each other, learning about each other's understanding while they're actually working on the model. On the flip side are formal model inspections and walkthroughs, things that are more formalized processes which involve circulation of items for review ahead of time, which involve formal presentation of a model, often not by the person who created the model, and involve creation of lists of items to be resolved following the peer review. These two we found tremendously beneficial in our group, and in most cases we find significant issues that require changing within the model within our peer reviews. So not doing them would have left very likely a lot of those issues latent, and potentially they would have come up at much more awkward times, such as after we had submitted publications on the model at hand. So when your models reach a good milestone, I would suggest the use of formal peer reviews, and there's whole books on the subject in software engineering about conducting them well. Early on in the process, I would encourage pair modeling and peer desk checks, where you take a model and you show it to someone and get their feedback on it. This can really help enhance the quality of the model. Another thing is preserving successive distinct model versions. We use version control systems in some cases, things like Subversion and Git, And AnyLogic does provide support for some of these. So if you go into AnyLogic and you go look up here, and you can find there are these menu items for Subversion and CVS. These are version control mechanisms. Subversion is particularly widespread within the software engineering area, and it can be very, very useful for giving you access to old versions of your models, allowing you to recreate old results from those, but also for comparing a current version of a model and a previous version of a model in a very succinct way. It also allows you to have a backup of your complete set of models. Now, this is especially valuable when you have several people working on the modeling project and you want to distribute the model, or several people work on it and contribute to it. It can help broker that whole exchange and make it possible, because a lot of these systems live on servers and you can get it from the server. Priyasaри talked earlier about keeping careful track of experiments, writing out results from particular experiments with the model. Highly, highly valuable. Perhaps most important on the process side is the importance of building a model incrementally. Building it up in a step-by-step fashion, running it, observing the results. If there's something unusual, investigating it, and either localizing a bug much faster than you would have if you had lots of new things in there, or gaining insight that you didn't have when you started this process, which could then guide you as to how you want to develop further on. So developing a model step by step by step will often get us to a more sophisticated model sooner, and it will do so with greater confidence that the model is reliable and robust. Moreover, it will get us there with greater insight, and the model that we produce after that time, that richer model, will often be substantially more informed than if we had sat back at the beginning and said, we want to build this model with these features in it and these attributes. It will have instead learned from observation along the way, and so the insights that it offers may be deeper. Lots of other suggestions here. One other thing that I hope all of you know about, but in case you don't, I want to highlight it, is the capacity in AnyLogic to generate documentation. If you go into right-click on a model and use the context menu here, you can find that you can create documentation on the model, and this documentation will provide summaries of the model information, and you can actually choose on what subpieces of the model you want to collect information. For example, do you want to include information on the presentation information, control information, charts and analysis data, state charts, connectivity, general properties? Do you want to collect it on the experiments? You can select accordingly and have it finish, and it can generate this in Word document, a PDF document, etc. This can be very useful for AnyLogic. Not only does it provide you access to visual representations, but it can also capture things that are otherwise scattered through the model, like little snippets of code that you forgot exactly where they lived. You forgot that they were there. So generating this model documentation is highly advised at different points in a process. And if you'd like to document the model for a peer review, you could do worse than starting with this accompanying your model. Okay? So those are some basic comments on model process. I have lots of other things here I would love to present, but the time is not in favor. So I'm going to have to stop now, and I think what I'm going to do is to switch over into a wrap-up mode where we talk about some final items. Bearing in mind that we still do have, for those of you who are interested in it, the job